Okay, now we're going to do acceleration versus time. So acceleration versus time. Okay, so this is in meters per second squared, and we want to see the units there written on the test. Okay, versus time in seconds. We know still that the car was moving for 8 seconds, so we can put that in. 1, 2, 3, 4, 5, 6, 7, 8. Whoops. Okay, so that's 8 seconds. And this time, the highest acceleration that we worked out when we just did the previous question here was 3 meters a second. Okay, so the graph doesn't need to go any higher than 3. So I'm just going to go 1, 2, 3. Okay. So in the first second, all you have to do here is graph the information that you just worked out. So here, we worked out that in the first second, the acceleration was 2 meters a second. So in the first second, acceleration was 2 meters a second. And, okay, so 2 meters a second in the first second. Okay. Then, in the first second through to the third second, we said that the acceleration there was 3. Okay, so up to here, we're going to go 3 meters a second. Okay. And after that, now you've got to be careful here, okay? When you're doing acceleration versus time graphs, you go blockwise, so you should have horizontal and vertical lines. So it should come across from the beginning, it should go up like this. Okay, so that way, in the first second, you're looking at an acceleration of 2 meters a second squared. In the first to the third seconds, you're looking at, for the whole time, an acceleration of 3 meters a second squared. So your graph should be horizontal at that point. All right, and then it says that the car maintains its speed, and we said previously that the acceleration in those last 5 seconds was 0. So we drop the line down, down, down. It should meet at the 3 second mark, and then across to 8 seconds. Okay, because the acceleration that whole time was 0, it stayed at the same speed. So pretty much all acceleration graphs should look like that. Okay, blocky with horizontal and vertical lines all the way through. All right. In question 7, all you have to do is describe what's going on. My advice to you is to divide the graph into chunks, okay? Anytime the line changes direction, you start a new sentence, or a new part of the sentence at least. So it changes direction there, there, there. Okay, so you've got 4 sections to describe in total, okay? So you describe this section first, all right? So what was happening at that point? Well, if this is displacement or position, displacement and position are the same thing. Okay, displacement at the beginning obviously is 0. So in the first 2 seconds, the person on the skateboard was displaced 4 meters. Okay, so you write something to that effect. So you say something like this: the student moved 4 meters from the starting point. That's where I got the 4 from. Moved 4 meters from the starting point in 2 seconds. Okay, then what did the student do? Well, if the student's displacement hasn't changed here, right, they're the same distance from the start that they were before, so that means they've stopped. All right, so you could say then, you could say that the student stopped for 3 seconds, okay, from 2 seconds to 5 seconds, that's 3 seconds. So the student moved 4 meters from the starting point in 2 seconds, then stopped. Okay, how long did they stop? How long did they stop for? For 2 seconds. For 3 seconds. For 3 seconds. Okay, so I've just summarized the first 2 sections here in that one sentence. All right, and then what does the student do? Well, they move. You can see how these are the same, right? So the student moved further away from the start, okay, for another 2 seconds, and then moved back to the starting point, okay, to be back there by the 10-second mark. So you just describe that. So then they moved another 5 meters away in 2 seconds. I've just noticed that this was actually 5 meters difference here. Okay, from 4 to 9 is 5 meters. Then they moved another 5 meters away from the start in 2 seconds before returning back to the beginning. Okay. Now, if you on the test were to miss out on, say, they took 2 seconds to do this, and then they did this for 3 seconds, and then it was 2 seconds here, and then how long it took them to get back to the start. That's not critical in this case. What you probably would want to do, though, is specify how long they were still for, and you would also want to mention if they, if the graph looks something like this, and they came back really, really sharply or really, really suddenly, then you would mention the word quickly or something like that to emphasize that this happened quickly and this happened more slowly. Okay, so just use your best judgment, but you want to be able to describe further away, stopped, further away, getting back closer to the beginning. Okay, for the next few questions, I'm not going to go through and explain every single one. I'm just going to display the answer on the screen, and you can go through and pause the video if you're not sure exactly what's going on, and just peruse those on your own. Okay, so here's B. Both students finished the race at the same time after student B gives student A a head start of 3 seconds. For C, the ball starts with an initial velocity of 1 meter per second and increases its velocity, as you can just see there, by 0.5 meters per second each second for 6 seconds in total. Okay, so you include all the information that's present. This one, it's not a specified object, so you just say the object accelerates at 2 meters per second for 2 seconds, then it maintains its velocity for another 2 seconds, then it decelerates at -2 meters per second for the 2 final seconds. Alright, question 8. In this question you have to draw a displacement time graph. Okay, so we set up some axes for that. Okay, and remember that this is displacement versus time. Okay, so we're only interested in where the object actually is. With this question, it doesn't really matter where you start, but it's going to go, let's just say that it's going up to start with. So it's going to get further away from the start, then it's going to slow down as the spring compresses, and then the spring's going to expand. It's going to come back to its starting position, and then the spring's going to extend. Okay, it will slow down as the spring reaches its maximum stretch, and then it will come back to its starting position, and it will repeat that process. Okay, and we call this sort of repeated motion, whether it's a spring with a mass on it or a pendulum, we call it oscillating. Okay, the question won't ask, there's not a question on the test that says oscillating, but it's a useful word to describe something that moves backwards and forwards in this wave-like sort of pattern, oscillating. And the last question on the front page, question 9, simply asks you to describe the motion of these objects, which is, again, pretty simple. We can see from this top one, if you look, you'll notice that in the top one, and this is kind of an important thing to notice, that the spaces between the numbers are quite even. Okay, so evenly spaced all the way along. Okay, so every time the camera has taken a frame, it's moved the same distance. Okay, so if you're writing a description of that, all you have to say is the object, which in this case is like an air hockey puck. The puck is moving at a constant velocity. Okay, so a constant velocity. It's not picking up speed, it's not losing speed, it's a constant velocity. And if you wanted to, you could probably also say that it was moving at a constant velocity in a straight line. In a straight line. Okay, so yeah, pretty easy. If the marks are evenly spaced, that means it's moving at a constant rate, right? It's quite steady. You can compare that with this one over here, where obviously the spaces are getting further and further apart each time. Okay, so it starts really, really close together, and then as it goes, they start to spread out further and further apart. Okay, so obviously that means that the object is getting faster. In other words, it's moving more in each subsequent frame than it did previously. Okay, so it's picking up speed, which means it's accelerating. So we would write for this one, very simply, that the object, I'm going to run out of space here, the object is accelerating. You could say picking up velocity, but that you just use the proper word, accelerating. The object is accelerating which direction? Downwards. It's important in this case to specify which direction it's accelerating in, because you want to make it clear to the person, or to me when I'm marking it, that you understand the difference between something that's getting faster and something that's getting slower. Okay, so if it was the other way around and these numbers were 1 down or 0 down the bottom here and 12 up the top here, then it's obviously going that way. Okay, so in that case it would be slowing down as it gets towards the top. Okay, so you must pay attention to the numbers.